Okay, today we are going to see principle of superposition. Principle of superposition is also called as superposition property. So it is applied for any linear system. It has wide range of applications starting from physics. In physics we use this principle of superposition. In waves we use this principle in geology. We use in many engineering applications. The principle of superposition states that the net responses caused by two inputs is the sum of the responses that would have been caused by each input individually. So just now I have told orally. So here you can see, for example, the input A gives a response of X, and the input B gives a response of Y. So now let us apply the principle of superposition for this case. So according to as per principle of superposition, the summation of inputs A plus B will be equal to X plus Y. So this is what the principle of superposition says. So just now we have seen what is principle of superposition, we have seen its application, we have seen its general theory. Now we are going to apply this principle of superposition in beams. So let us, we are going to apply this principle of superposition in differential of beams. So here I have given the formula to understand the principle of superposition. So we know that delta one is nothing but the reflection of at reference point, the reflection of a beam at reference point due to load at point 1, say P1, and delta 2 is nothing but the reflection of a beam at reference point due to load at P2. So now, as per principle of superposition, the reflection of these two different cases will be equal to the reflection of a beam at the reference point when the both loads are applied simultaneously. So this is what the principle of superposition says. So just now we have seen the formula to understand the principle of superposition. So now I have shown the schematic to understand the principle of superposition. Let us take a beam. You can see a beam. I have shown in a line diagram. So it is a simply supported beam that both ends are simply supported. So I am going to apply a point load at point 1. I am going to apply a load at point 1, say P1. So because of this load that reflection, so I am going to measure reflection at a reference point. Say I am going to measure at the midpoint of the beam. So due to load P1, I am getting the reflection of delta 1 of this beam. Then similarly for case 2, again the same beam, I am taking the same reference point, which is the midpoint of that beam, but I am going to apply the load at point 2. So I am going to apply load at 2, say P2. So because of this load P2, I am getting reflection of delta 2. Now as per principle of superposition, I told that delta 1 plus delta 2 equal to delta 1 2. So now let us see what is the case 3. So as per principle of superposition, to verify that delta 1 plus delta 2 equal to delta 1 2, we have to apply both P1 P2 simultaneously, and we have to measure reflection at the same point, which is the midpoint. So when I apply load P1 and P2 simultaneously, then I get a reflection called delta 1 2. So this delta 1 2 should be equal to delta 1 plus delta 2. This is what the principle of superposition says. And then we will see the equation, and then we will go to the experiment. So just now we have seen the theory of principle of superposition. We have seen the formula, and then we have seen the beam schematic. Now we are going to see how to get the readings from the beam. So anyway, you can see. So there is one column for load. Here we have written the applied load. For example, scene number 1, we have to apply the load. Say I am going to apply 0.5 kg. So kg already is mentioned. So I am going to apply a weight of 0.5 kg or 500 grams. So for that, I have to write the corresponding reflection in mm, say 0.8 mm, and then I can add load in different steps, say 1 kg, 1.5 like that, and then I can note down the loading accordingly. And also finally, when I remove the load, also I can take the unloading reflection, and then I can average it. So the purpose of taking unloading deflection is to get the accurate data. So as I told, to prove the principle of superposition, we need to have three different cases. So case 1, I apply load at point 1, say P1. So, and then after doing this experiment for case 1, we have to move on to case 2. For case 2, we need to apply load at point 2, that is P2. I need to apply the load, and then I need to get the reflections accordingly. Say point 9, something will come. So that again I have to do the steps. I can increase the load in a step of 0.5 kg, and then I can take the load deflection. While removing the load, I can also take the unloading deflection, and then I can average it. So now we have done case 1 and case 2. Now to prove the principle of superposition, we need to compute the delta 1, 2. So to compute delta 1, 2, I need to apply the load P1 and P2 simultaneously. P1 plus P2 at the same point, same load. At P1 I have to apply 0.5 kg, and then I have to apply 0.5 kg at P2. Now I have to compute deflection. So it would be around 1.763. So like that I can add the loads in a step of 0.5 kg for 3-4 readings. For each loading I have to take the corresponding deflection. After doing this, we can unload the loads, and then I can capture the unloading data, and finally I can average it. So if you compare that case 1, say delta 1, you get some value, and take the deflection from case 2, say delta 2, should be equal to the deflection of case 3, that is delta 1, 2. So this way we can prove the principle of superposition by using deflection of beam.
For principle of superposition experiments, we have the beam setup. We have a simply supported beam supported by 2 columns with a mild steel beam of 800 mm length and 12 mm wide with 6 mm thickness. So for principle of superposition, what we have here is the point where we are applying load is available here. So there are 2 points. So we choose this one and this as 2. For first set of experiments, we are going to apply load here and measure the deflection here. For second set, we are going to apply load here and measure the deflection here. For the third set, we are going to apply load simultaneously on 2 points, and we are going to measure the deflection here. So the deflection measured at this point by the load applied at this point, we call it delta 1. For the load applied at this point, the deflection measured at this point is delta 2. For load applied at both points, the deflection measured at the center point will be delta 1, 2. So the sum of deflections delta 1 and delta 2 will be added together, which is equal to the deflection caused by those 2 loads together in the center. So that delta 1, 2 will be delta 1, 2 will be equal to delta 1 plus delta 2. This is principle of superposition. First on the loading at P1. Okay, 1. This is second 0.5. This is third 0.5. This is the fourth 0.5. Fifth 0.5. Okay, done. Unloading. 5, 4, 3, 2, 1 is removed. 0. Okay. Load application at point number 2. First load. Okay. Second. Third. Fourth. Fifth. Unloading. 5, 4, 3, 2, 1. Now simultaneous loading. 1, 2, 3, 4.
Yes, you can go ahead assemble. First weight hanger. Then placing beam on the support, position the weight hanger. Right. Next, dial gauge. Fix the magnet and adjust dial gauge for 0. Perfect. Okay, dismantling.